Whereas deep learning can learn by itself and it will also improve by itself and it can fine tune by itself based on the data. It gets fine tuned like. So ChatGPT is based on deep learning technique. So, of course, to talk with, this is a very common figure which is found at certain many of these places. So when I talk about machine learning is divided into three algorithms or subset into three things. One is called supervised, and second one is called unsupervised, and third is called reinforcement learning. So you have supervised learning, unsupervised learning, and reinforcement learning. When we talk about supervised learning, of course, we have a regression and classification. So if you would like to predict something, then we do regression. Of course, there are a lot of regression methods. I'm not getting into that. Like suppose he given life estimating life expectancy or weather forecasting or population credit prediction or increase of houses in next 2 years or 3 years, increase of prices of vehicles in next 2 3 years. Everything is done as a part of a regression analysis. They're a part of. So if you would like to predict anything, like even in the failure of slope failures and all, we use this regression analysis. Whereas the second part is called classification. This is very much used in transportation engineering. And even we use in structural health assessment and monitoring. So what are the different types of class of vehicles which are going on the road? Or how many different types of things are there? Like you have human beings, you have animals, you have vehicles. So how to segregate? They classify automatically. We don't name each person, but classifying things is largely about supervised learning. It's about classification. And unsupervised learning, uh, we don't teach anything, but it can cluster into these things. Like apples are clustered. We don't know the name of apple, but they are clustered. If you go to any supermarket, all the similar kinds of items are kept at one place. That is called clustering. If you give some kind of a data to unsupervised learning, it can cluster all the kind of data. And there is another thing called dimensional reduction. Uh, so it is something like this. You can actually compress the data. You can remove certain parts which are not important in trying to understand a person. Like if there is a human being, maybe everybody has got eyes, nose, and mouth and ears. So all such kind of redundant data, it can be removed. It takes another kind of parameters to distinguish between them. So that is dimensional directionality, and reinforcement learning is by experience. So these are major, and even for our research also, we have used a lot of these things. We'll also come back in some examples as well. So human being learns from his past experiences. So like cycling, driving, eating, and based on that, we have decision making. When you go to engineering college, you make friends. So on the first day, we make everyone friends. Based on your experience, slowly you will have one more group. And you may not talk to a lot of people. So slowly it narrows down. It's based on your experience, you take decision and you go forward. So all these are done by human beings. And machines follow instructions given by humans. Till today, it was like that. So we have to control the machines and we have to give it direction so that it actually takes the instructions from human beings and it acts accordingly. The same thing, you can see this. Human beings are training machines what to do, what not to do in a small or a big way. And machines used to do by the instructions. In fact, most of the manufacturing companies have these machines which take instructions and they do a routine job. Now, what we are trying to do right now is what if humans can train the machines? So now I am telling this machine that this is Apple, another thing Apple, and another thing Apple, and I'm giving this object to machine. So machine is thinking on it and it is telling, oh, this is also an Apple. So this is what we are trying to do. We are training machines, and that is what is called machine learning. That's what is called machine learning. For example, this is the most simplest algorithm. There are hundreds of names of algorithms, like you have random forest, decision tree, nearest neighbor, you have Bayes theory, you have a lot of algorithms, but all these algorithms work on a very simple thing. Suppose you are listening 100 songs. You're listening 100 songs and you're telling me that you like this song, you dislike this song. Now, when you like and dislike this song, I'll draw a plot of these 100 songs based on tempo, genre, intensity, and gender. Like, female sings, male sings, like you have intensity, high intensity, low intensity, you have a tempo, everything. Now, based on intensity and tempo, I have plotted all the songs. This is a relaxed tempo and this is fast tempo. Intensity is light, intensity is high. Few people like that. So whenever I'm taking the data from you, so you said this song, you're right. So you like one song. So I have seen that song has got faster tempo and high intensity. Like that, I have plotted. And I have seen that all your songs of liking are more into high intensity and fast paced. And the low intensity and relaxed tempo you did not like. So suppose if there is a new song which has got a higher tempo, then obviously I know that this is the song which you can actually you will gonna like it. But if there is any song which is out of this two, then we'll see this distance to the nearest of liking or unliking. So based on this distance, we will tell whether you will like this song or not. So this is called K nearest neighbor. This is the simplest algorithm. I am not trying to teach all the algorithms, but fundamentally, this is a statistical analysis. Statistical analysis. And this statistical analysis will give us whether you like or not. So that's most of the algorithms are based on simple uh, distance measuring, or this is how they work. So in YouTube, when you watch a movie, then it is going to recommend similar kinds of movies. When you watch in Netflix and similar kind of a movie, it recommends all these things. How do they decide all these things? Your code will calculate all these things in the background and suggest what kind of video you would like to watch based on your interest and based on the past data. As your data or watching movies increase, your suggestions by the computer will also increase and it will get fine-tuned as well. Now, that's the part one. The second part. So that's how the algorithms work. That's how the data is going to work. That's how it's going to get refined. And that is what is all about artificial intelligence. And it's all about five senses decision making. Now, why suddenly so much demand? The so much demand of artificial intelligence today is because today we have more computation power. There's only four major points. And the second, today we have more data like Aadhaar card, and we have better algorithms, and we have a lot of investments and a lot of profits as well. These are the four major points why today artificial intelligence is in high demand. Previously, we didn't had the computers of the fast as the day today we have that, and we didn't have much data digital format. Today we have data digital format, and we have the best algorithms, and in fact computers themselves are improving and we are trying to get better algorithms. Now, that's all put aside about what is artificial intelligence, what is the simplest algorithm, what is statistical analysis, and why so much demand. Let's come back to the civil engineering. Why do we need AI in civil engineering? Of course, we do have a lot of problems around us in civil engineering. First, you can see one of the big thing. Even today, also there's a huge rain in Mumbai. There are a lot of buildings which have got collapsed. A lot of huge traffic jams are happening everywhere. Not only in Mumbai, but majority of the cities where it's rain, it's havoc. And it's not only in India, various other countries as well. We have a lot of this problem. One of such kind of a problem is traffic accidents and traffic pollution and a lot of traffic jams, especially during the peak hours. Can I do something here? Yes. So let's see what are the other problems as well. So you would like to know people who are stranded in the floods, and something have to go, and we have to know where is the high population density during any kind of a natural disaster that we wanted to know, and we had to evacuate. We need solution for that. And third is the water pollution and wastage segregation. There's a lot of mixed water pollution with a lot of other kinds of ingredients. It's becoming very difficult to classify them or segregate them. This is another challenge, and a lot of building collapses and other things as well. So all these problems are there right now existing, and there are a lot of engineers, MTech level, BTech level, PhDs or research scientists. They're all working on this. Now let us see 4 or 5 examples before we get into the research problem. So civil engineering with AI is another revolution, and technology has taken a giant leap here. Like you see, this is one of the first such kind of a crossover between architecture and AI. So AI has started to develop some kinds of a geometrical designs which might be useful for human beings. So your softwares are trying to give designs or suggest human beings that this might be a geometry. After a lot of trial and errors, trial and error, trial and error, trial and error, and compute a lot of feedback or inputs from a human being, bridges have slowly evolved, and this is a complete bridge analysis and design done by suggested by an artificial intelligence. So you can see how the transformation from the previous slide to this slide has taken place. So you can see this. So they have given that there is an footpath or it is a foot or bridge where human beings should walk and cycling should also be allowed. Then you can see how a computer has come up with a geometrical design. Now, when this bridge was analyzed for the first time, this one bridge is resistance towards the natural disaster in terms of floods, in terms of air, in terms of aerodynamic. And the second thing, this is first, which is resistant towards the natural disasters. And second, you can see the design is so sleek and material is so optimized. The construction was, it was suggesting with a 3D printed interlocking mechanism elements. So even the material is also minimized and the life of this is also be very high. So this is analyzed and designed by a computer, and this is already built in Norway. So there's a myth. Most of us think that myth AI in construction won't be taking jobs, rather it will be saving lives. I also would like to add one point here. It's not biased, but AI at the beginning seems to little dangerous, but slowly it is just an addition to the human being intelligence, but not take a lot of jobs. But it's gonna save a lot of lives in the construction sector. Now, coming back to this applications of AI in civil engineering, of course, there are a lot of applications and it's not limited. It is used in structural engineering, geotechnical, environmental, transportation, water, surveying, construction, earthquake, materials, and coastal. Of course, we have seen applications of AI in all these applications, but at least I wanted to discuss one thing in detail. So I'll have a very short description of few things and other things I'll tell it in detail. I said in structural engineering, right now, if you have 100 buildings which are analyzed and designed in Hyderabad, and which if you can give it to a software like ETAPS or MIDAS or ANSYS or STAD or anything, they slowly change the geometrical features in such a way that these geometries are very much stable to the current analysis and design. Current analysis and design. So this system, you can also write your own code. Of course, this is if somebody is really interested, then they can actually look into Google Colab or Kaggle, where you have a lot of data sets related to this. And Google Colab is where you can compile your codes as well. And you'll also get similar codes as well. You have to just fine tune these things if somebody is interested in that. Anyway, so structure analysis and design is largely about optimization of the geometrical. And this is also one of such kind of a design which was suggested by AI. And AI-powered drones and robots, they are currently used for inspection of bridges, building damages and cracks elsewhere as well. Hong Kong is one of the country. Dubai is another country. Hong Kong, anyway, I know one of the company which is all the buildings are inspected by with the help of a drone. Drone goes there. Drones are also cleaning the high-rise structures in Hong Kong as well. Now that's one of the big business in Hong Kong. Recently we've stated that. And predictive maintenance. So AI algorithms can be used to predict whether a structure will require maintenance, thus reducing downtime and costing. Much before the actual kind of a damage, AI can tell that based on understanding the behavior with sensor information and all. And this is also like smart infrastructure, smart structures. This is also if you're trying to tell a system that you would like to come up with 3D printing material, not with actual concrete and steel. It actually suggests different types of designs as well. You can see this smart structures as well, design anything. And it will also tell about natural disaster. And third, is, and third, so AI algorithms can be used for scheduling, resource allocation, quantity control. Now, with the help of a video, you can tell how many vehicles are coming into the site, how many vehicles are coming into site, how many vehicles are going out of the site, how many people are working. Everything can be done at the construction site. This is actually part of the construction management. And it will also able to quantifying certain materials as well from the video as well. Now, like an architect, one of the architect asked AI to design a skyscraper for the future. And this is what the AI has given. And it's thinking that we are just trying to have a lot of deforestation. It is trying to have afforestation or a green buildings, a buildings with a lot of plants in and out for actually taking care of the pollution which is released into the atmosphere. They are also thinking about greenhouse effect and environmental pollution as well. So extension to this, it has actually given how each plant, how each material, how each house can be planned in detail. You can go through this article, which is available online, and most of my pictures which are taken online have the links below. So it's not only the image which is given by the AI, an app, but it is actually giving in detail how these structures can be built, what kind of materials it can build it, how much time will it gonna take. Everything is given by the AI now. But all these are possible because there are a lot of information which is already given to the computer to understand how the construction is being done. Different materials are used by human beings as well. You can see how sleek, how geometrical features are there which can resist floods, rain, environmental, sun, sunny days, ice, wind, everything. So based on the geographical location, AI is trying to give all the features related to the infrastructure, which might be part of the next future. Now, this is there. This is I took from the online, but we are also developed. This is all about augmented reality and virtual reality, where you can develop the model here, and you can tell by the instruction. You can talk and you can create, or with the help of your hands, you can change the geometries or increase the number of floors, and you can change the geometry. Or directly you can project a 3D diagram from a 2D plan as well. Now these things have become very common, and these are all are possible. This we did in 2017 of getting a 3D from a simple 2D plan. And it's not only that, people can also have a complete planning of a small town or a small city, and then they can see how does it look like after building, or if you want to remove some structure, how much space is available. Everything can be done digitally now, and you can actually feel the whole place just before it is constructed. And even after the construction, if you want to replace any structure, one structure with any other thing, that can also be done. So this is all possible because now we are trying to started communicating with machines very efficiently, and machines have also suggesting humans what to do. Now, this is another thing where you are actually trying to have that, okay, how does it look like if this is indoor place with the grass? How does it look like if this is an furniture shop or furniture place or any spiritual place or something like that? So you can think and tell, and accordingly your system can change accordingly and show you, and you can actually feel it. No, previously all these were all like a 3D walking, or architects used to make a 3D walk. But right now it's not 3D walk. You can actually feel it. So all these are being done in really. And this I took from online, but these are also possible that a person is trying to project all the building plan, everything online here, and then people are there from different countries and they're talking to each other and changing accordingly the plan. So these things can happen. This is all about a mixed reality as well. So there's another one, mixed building information model, where you have architecture, construction, like engineering industry. I think some of you might have heard about Microsoft station, or Primavera, or a lot of these softwares, which were used in scheduling of a project, they're all used for project management. Today, your building information model can have several layers, and with the help of artificial intelligence, you can have synchronized and sequential activities, parallel activities automatically with very minimal optimization time, and also what kind of obstacles which might come in the construction site while doing or adopting this procedure is also given by the AI as well. So all these are all effectively enhancing the time duration of construction at the site and also the construction management as well. And another one, very, very important is when people are getting home loan. How do we evaluate that? So now we have automatic evaluation of structures as well. Most of the banks would go there, take some pictures of like you have insurance of vehicle. In the same way, you also have the loan on the current existing infrastructure as well. Now all these are being done automatically. Drone takes images, and some small vibrations are taken from the building, and it actually gives the current health of the structure, and they know the location of the structure, so they actually calculate what is the cost of the location and other things, and automatically property evaluation is done. And these are all are, again, these can be done by BTech students. They can take some 10 houses of a same region, and they can have 100 square yards, 200 square yards, 300 square yards, accordingly concrete building, mud building, bamboo building, steel structure, everything, and can be calculated, and this can be done as a BTech project. Now, this is another thing. You can see this is developed. So, Iris is one of the model which is already there online. You can use online tools right now. You can install this app, and it can convert your 2D plans into a 3D real structure. And in 3D real structure, you can actually communicate and actually change a little bit of interior furniture or any other thing that can also be done. Now, it can be two-sided. Previously, it was only one-sided. You can only get the 3D, but today you can also change the interiors of that as well. And here during the construction, you can also see different layers. This is VR augmented reality. So when you click on these sites, you can actually see only structural work, only architectural, only mechanical, only plumbing. Everything can also be seen. During the construction, you can update, and the owner can sit elsewhere and he can see the progress of the site as well. What is the mechanical work which was done here, or civil work which is done here, or electrical done, everything can be seen by sitting elsewhere as well, by taking the actual data from the site. If you see, this is done in 2012, now this is in 2025. Now automatic all the data construction site is injected here. You can actually see the real site instead of only the simulation part today. Now this is, we have also developed similar kind of a thing where you can actually see if there is any kind of a damage or any kind of a work which is unfinished, can be done, can be seen. Not every person can actually look and tell what are the kinds of problems at the site. So you have to take a video, and automatically your AI will tell, okay, there is a plug which is missing there, there is a wire which is missing there, or there is some kind of a problem here. It can tell or update what is really happening or anomalies at the site. Of course, I don't talk about smartphones. Smartphones now today with your cell phone, you can actually control all the electronic gadgets at your home, and you can also have some kind of a programming where automatically things might be switched off, switched on. Everything can also be done automatically. These are all about smart homes. And there are some modular construction where AI are giving designs in such a way that every panel can be off cast, and they can be casted, and they can be interlocked. Mahindra University is one of the university which is using completely prefabricated segments, structural elements like this, and they are using construction, and they built almost like 12 to 15 story hostels. Of course, it does not have so colored. Color is done after the construction, but yes, with windows, even including the wiring as well. Wiring, which means the slots can be connected, and wiring can be done after the locking of the panels. And another one, 3D printing. So 3D is one of such kind of a thing which is there already in last 4 or 5 years. But what kind of material which can be mixed at what kind of proportion and how it can be printed 3D. Now here it is mud and it is a gobar. You can see they are actually trying to have a 3D printing of a natural friendly or nature friendly material is being used for the construction. And after the construction, okay, this is how the completed building looks like. And this is also another 3D printed one. So the future 3D printing can be done of the whole colonies or societies can be built only with 3D printing as well. But one of the most important is the mechanical system and the composition of the material which is mixed. Now this is AI's been used widely in understanding the materials and the geometries. This I don't know how many of you heard, but this is called biomimic. Biomimic is you mimic geometry from the nature, and they are very, very stable in terms of structural design and structural construction. They are very much resistant towards wind and others. Like Burj Khalifa is a building which was inspired by a lily plant, or at least families of a lily plant, and it is very, very one of the very, very stable structure. So now AI is helping in adapting nature geometries for material usage and for the resistant towards natural or human-made disasters. Like honeycomb is one such kind of a structure, and you can see this honeycomb for blue or this. And if you heard about some project called NEOM, NEOM is 170-kilometer long project which is being constructed in Saudi Arabia and 500-meter tall. This is 500-meter tall and 170 kilometers. It's called Line City, and they have given that AI is the beating heart of total this city. It's completely like a mall, indoor mall, but it's a whole city which is being built in a line. You can just see a video in YouTube. But AI is largely used in now in city planning and city controlling and implementing all rules and regulation. Everything is done with AI in this city. So it has got true nature. There are places where it will rain continuously, so snow rain, snow continuously. That summer you have a lot of such kind of being prepared artificially. And then you might have seen James Bond movies. I'm telling some examples which are already there in the world before I actually tell our research. Cracking is major problem in the construction and on roads as well as buildings. Now, Purdue University, one of the faculty has come up with like AI-driven monitoring or maintenance solution, enable self-healing roads and bridges. So suppose there is a crack this came up in the concrete, and suddenly you see that after 5 minutes this has healed by itself. Whatever it is, kind of different materials which are being used in this, or different types of bacteria which were being injected into the concreting, so that even after the cracks appears, they would heal by themselves. So AI is working on that as well. And transportation engineering, this is another one of our favorite project where autonomous, where right now we are trying to understand the driver behavior based on the face feelings, like whether driver is frustrated, whether driver is smoking, driver is drunk, driver is likely sleepy or any other thing. So based on the facial recognition, your AI is telling what is the current state of the driver. Accordingly, it will recommend driver whether to drive or recommend to pause for a little while. And traffic management, I think local engineering colleges also have developed traffic management. Traffic signals can talk to each other, and every light can become green or to in such a way that actually it gets cleared for the ambulances. So these are being done, but the implementation there is a challenge. So it's going to take some more time for to see all this in reality, maybe in a couple of years, not more than that. An intelligent transport system today, you don't really need to count any of these vehicles. We have to do the video analytics automatically. The code is gonna count all the number of vehicles, class of vehicles, and it can also tell the speed of the vehicles as well. And fleet management is like you have a lot of aircrafts, lot of trucks. How do you manage them? There also AI is being used. And payment design. So this is automatically when you have a camera on a car, when it goes, then it actually gives what are the number of potholes, how many number of potholes, and what is the amount of material which is used for repair as well. I think Bangalore has come up with this, and Hyderabad is coming up with this, and metropolitan cities are coming with something called smart parking, an app where from surveillance cameras, smart parking wherever the available parking slots are there, that is actually presented in the app, so that any person who is going new to that place, then he or she will know where exactly the parking is available, and so that they can go and actually park their vehicle. The smart parking, and I think it's going to come it's going to come. It is in the trial basis in Bangalore, in Hyderabad, and Delhi, and most probably you would see that in near future. Okay, transportation engineering. Anyway, I already said this is autonomous vehicles is one of the first challenge. Autonomous vehicles now in the tier 2 or tier 3, where vehicles are able to recognize the vehicles in front. They are able to slow down. They can increase the acceleration and they can avoid accidents as well. All these things are being done by autonomous vehicles. Very important for civil engineering. So these are the there autonomous vehicle camera, LiDAR, radar, and GPS unit. LiDAR will tell about the whole circumference. LiDAR will tell about the distance, and camera will tell us what are the different types of objects. And GPS will tell its location with subject to the spatial information. All these are there in autonomous vehicles, and this is how a vehicle sees. And there are a lot of other things also. Address delivery, automatic deliveries. You just have to leave it to society and you give OTP, it will open and you can take the delivery. So these are all starting in the universities and societies. So slowly, I think this is already there in US. I think Hong Kong, it is already there, and Japan, it is started. And in India also, they are starting into this one. Drone delivery also. Why AI is utilized for drone deliveries and all? Because from the image, it has to recognize where they are landing. Image recognition classification, they actually try to know which place and everything. So drone delivery is another thing where AI is coming to the picture. So geotechnical, I said, just I'll tell you the names where geotechnical largely it is used. So site characterization. These are support vector machines or generalized regression for neural network, soil and rock classification based on soil data. Now, like soil stability analysis, IIT Mandi is working largely on the soil stability analysis by using various multi-layer perceptrons or regression analysis. A lot of other codes are being utilized to understanding the slope stability analysis. Right now, it's becoming one of the challenge in India. And then yes, they are using, and they are also figured out a solution for that one as well. And then you have groundwater modeling, and then pavement design, the same thing, and construction monitoring, which I already said in previously. So geotechnical engineering based on the soil profiles, and they are actually trying to calculate the pile capacity, settlement of the foundation, liquidation, slope stability, and all. Again, this is another thing. I don't know how many of you know this, but Indian government has come up with waste management recycle. All the waste is dumped into one of the recycle plants, and it will tell how much plastic, what is the paper, what is wood, what is everything, and accordingly this waste is being segregated now. This was an undergraduate project, and now they slowly starting into waste management or recycling plants. Slowly they wanted to have automation of segregation of waste, at least solid waste, if not the liquid and other things. Solid waste they are trying, and it is working, and it is working very effectively. And then we have smart cities, of course, disaster response. All these like tsunamis and all now are being simulated with AI, and accordingly it will give warning to which kind of buildings they have to evacuate at the first or the second based on the intensity of the simulations. So all these are being done in various forefronts of civil engineering, like environmental. These are some of the plants where water is given only based on the dryness of the soil. And this is one thing where your actually robots are actually plucking the fruits, plucking the grass, everything. They can pluck based on the requirement. So all these automatic robots are being developed, and it is working. And this is irrigation based on the scanning. how much fertilizer has to be spread. The first scanning will be carried out, and accordingly fertilizer is taken, and accordingly fertilizer is spread across the fields. It's not uniform. Now it is based on the requirement. So it's a huge improvement. And I'm sure based on all those things, Indian Railways wanted these things at the construction site because they see lot of materials which are missing at the site. So they wanted to know how many trucks are coming in, how many trucks are going out, how many people are coming in, how many people are going out, everything. And they wanted to know the difference between the vehicles which are used for construction and the vehicles which are used for people for their travel, everything. So all these things are done automatically today on the code using CNNs, mass car CNN. And drone and AI, see, this is already there and implemented in construction site. It can actually, you can see it is a carpenter, and you can see is a bar bender, and you can see another person. So based on the concreting person, based on their kinds of dress and cap, the code can actually segregate and can tell how many people are there in this segment, how many people are there in this segment. Now this has become much easier at the construction sites as well. And this is another thing. This is automatic drone and AI for maintenance. They go, they actually take images and they see any kind of corrosion or cracks or any failure of their machines and all. They'll actually see. Similarly, in the construction of any power plants and other sites as well. Now, just before I get into our research last case study, I'll just tell in 10 to 15 minutes. So these are all our automatic machines which are used in the construction sites like plastering, bricks. A lot of countries, European countries and UK, US, even in Indian companies are trying to come up with automated machines which might be used in the construction. Maybe this is this is our case study. We have seen a lot of case studies, but I said it in general. But now I'll talk largely about our contribution to Indian Railways. So this is automated damage detection and quantification using AI and drones. So we have started this work 1 minute way back around 9 years back, and these are all unmanned aerial vehicles. So this is our team anyway. Me and she's from computer science, and this project specially is done by Mustafa, Revan Sagar, and Datri. She is from BTech Computer Science, and both of them are MTech in Structural Engineering. So, of course, special thanks to Indian Railways more than NHI because they have given permission to do a lot of cases on bridges in India. This is in Kyoto. This is myself, and this is Professor Kim at the Kyoto University. And we have my PhD students who have attended this session in Kyoto as well. This work is in collaboration with Kyoto University in Japan. So one of the big challenge right now is when we go to the site in inspecting the bridges, we have to take ropes, wires, and we have to take a vehicle in inspecting all these things. So it's becoming very, very challenging to have a manual inspection of these bridges. So this is our students, our research students who have actually, you can see how they are crawling, and we have to get on top of that to install sensors, and we have to take some kinds of to know the rivets or other things as well. So, and you can see here also how we were trying to work in getting certain geometrical features of the bridge. Sometimes this is very challenging and very, very risky as well. These are all part of our project while we were at the site. We did more than 1,000 bridges all over India. So now what we did, we thought, why is that we have to go there in the first place? Why not use technology? So we came up with something called photogrammetry, and we used a simple camera in our research center, and we took images. If this is the object, we took images from this height, we took images from this height, and we took images from this height, and that too in a circular way. And then we try to reconstruct the object like this. So this is the 3D reconstructed, and this is concept is called photogrammetry. And the photogrammetry can be done with a cell DSLR camera or with a drone or RGB. RGB depth will give us the damages in the structure. And drones can take a path and get the complete reconstruction of that. So this is another FOB, a prototype FOB in our research center. And if you see the coincidence of one image and other image has to be greater than 80% to get the actual quality. So this is the 3D reconstructed one. I'll show you another one as well. So then we did in the laboratory with the cell phones and we took a drone and we went on to the actual site. We went on a Gandipet site, which is nearby to our university in Hyderabad. And we took a drone and we went and did the actual bridge, masonry bridge site as well. You can see how we flown the drone and took the images of the complete of this bridge. Now this is structure from motion. I'll just tell you that you can use any of the free obtained softwares where you take all the images and those images are converted into point cloud and from point cloud to the actual 3D this. So these are the number of images which we have taken in the lab and these are the number of images which have taken in the real site to construct. So all these are really constructed bridges. So now this is what is completely 3D reconstructed model. So instead of a person going to the site, you can actually sit in your research center and can actually look what is happening to the bridge from here. So this is the 3D reconstructed bridge. Now, anyway, I will not get into this technical stuff. Has actually taken 1 week or we took almost 3 months to develop that. But right now we are able to develop everything, taking images, everything in a week or 10 days maximum. So this system has got 64 GB RAM and it took us almost 3 days to compile everything. So for rendering, it takes three days. And this is anyway workflow. After that, what we did, we have visited some hundreds of bridges and took images of only damages like crack, vegetation, water seepage, and motor loss. Even in the concrete, also crack, corrosion, and spalling as well. Now, what we did, we told computer after 3D reconstruction, you have to tell if there are any damages on the bridge. Then, of course, we did train. This is all YOLO, CNNs. I'm not trying to get into pure technical stuff, but I'm trying to tell you what we did. And then we have given unseen images by the computer and computer, we were astonished. Computer was giving what is the water seepage, what is the vegetation, and then if there is any cracks in this one, any kind of other kinds of damages. So once we trained, computer was giving everything automatically. So what we did, now we have a bridge of a 3D reconstruction and highlighted with all these kinds of damages. And it can actually tell that there are 10 spots of water sewage, 10 cracks, and there is a 10 spalling and 10 motor loss. Everything it can tell in terms of a quantification today. So we are able to do that very successfully. And apart from that, not only that, we can sit in our research center. I can actually measure all the dimensions sitting here. Can see this. Now we have written a code automatically. It will give the dimensions of the bridge as well. We have written a code. It is in the process. We tried it. It is working. So automatically it will give the dimensions of the bridge and it gives us the plan and elevation of the bridge as well. So this is we have seen. So this is from the on-site and this is from the 3D image which we have reconstructed. Almost 99% it is matching with the actually with this the ground measurements. It's almost like 100%. Now you can see comparison of models and 3D reconstruction of the models. You can see from here. Now after this, we have also did other railway bridges like you can see this is another railway bridge. And this is a steel and concrete, all other bridges and all other bridges dample also. So after that, by using another code, we have actually tried to quantify the damage. So now you can see we are able to do the 3D reconstruction. We can classify the damages and we are also able to quantify the damage as well. So any given bridge, now we can tell that, okay, this is the bridge. It has got 4 types of damage and each damage, this is the area and this is the required repair material also. We are trying to do that also. How much retrofitting, how much does it cost is also done automatically. Now, after that, what we did, if somebody is interested to feel like they are at site, we converted this model into virtual reality model. Now you can see our research student is actually going at the site by having this. We have 3D reconstructed and it is like you are going into site and inspecting the site as well. Now, instead of you go to the bridge, we are trying to tell all the railway engineers or more engineers that we will bring bridge to you and you can inspect sitting at your place. There is no travel. This is only drone which goes, take all the measures. We use 3D reconstruction. We give it the model. You can do the inspection from the office. And after that, if we have a video, and then now this is the actual video, and now this is our CNN model where it will tell us vegetation, water seepage, motor loss, everything automatically. So similarly, these things as well, influence on the video. And we have also worked on railway maintenance as well. Like when you use a drone which goes on to the railway on the tracks, it's gonna tell about the obstacles on the railway tracks, or it can tell this is an automatic obstacle. So we have used deep learning with vision transformers for optical detection on the track health monitoring. This is also one of the project which was done by AI BTech students, and it tell about how many number of people are also there. It is also count on that one as well. Apart from that, when you have a video from a computer or from video or a camera which is attached to the train, it can tell how many number of sleepers, how many number of fasteners. In case if there is any kind of a missing fastener, it can tell by red color. You can see this. There is a fastener which is missing here. So this is also we done, and this is also we gave it to the Indian Railways. Accuracy is 99%. So these are only images. I think it's lot in a single shot. We did lot, but I did not talk about the. We did not talk about the algorithms. I did. We used largely. We worked on transformers, LSTMs, SVMs, and CNNs, mass car CNNs as well. So these are some projects which we did. We are developing now Indian traditional structures in 3D, and we want these structures to talk to you, and they have to tell about science, engineering, and technique behind the construction. So because we are constructing too many concrete and steel, somewhere the traditional knowledge, the knowledge which has been evolved during the ages of building natural structures have to be kept somewhere. So we are developing this DJ Encyclopedia of Indian Traditional Houses. So all these structures are being developed and the structure can talk to you. And this is IoT based bridge monitoring. We have a different types of sensors which are kept on the bridge. This is what we have developed. And you can talk to the bridge and you can ask bridge when is the last maximum deflection. It is going to talk to you. So we have developed agent as well using large language models or LLMs. And this is heritage structure also. We are trying to decrypt how it is the science or geometrical behind the temples and its stability over thousands of years. So we are working on that one as well. And this is automatic. We are also trying to develop a digital twins for heritage structures as well. This is also part of our project only. All these are part of our projects, heritage structures. And this is one of the case study which we did in Japan, in Yokohama, where we are trying to develop, trying to see the difference between the actual designed structure and our actual existing structure. And this is how we excite a structure by hitting with a hammer. This is me, and this is my friend. And this is my friend. We are jumping on the bridge. We excite that. And this is what is the designed one. And this is the one which is existing. This is what is now this experimental is the one which is existing at the site. And this is designed. We are trying to find the difference. Even in India also, we're doing the same thing. So these are all different tests which did at the real sites in understanding the structures and sensors and day in day out testing with Indian Railways. And this is automatically our code can tell how many cracks are there, when is the actual point of failure in compression testing, and it can give us the length of the crack, width of the crack, and everything. And if you upload this is in this app, upload an image, it will tell what is the length of the crack, width of the crack, and properties of the crack as well, which we developed in 2017. And so all these are different types of research projects which we did using AI. So finally, I would like to tell a small summary. AI is helping us to enhance in decision making, especially in optimizing the structural analysis and design. Now we are largely doing predictive maintenance safety. We are doing structural health assessment and structural health monitoring with sensors and drones. Believe me, it's working amazingly very well. And then we have actually are able to predict the failure of bridges much earlier, at least 5 or 10 or 20 years more before, by telling this is the structure which is deteriorating and this is the retrofitting which have to be done, so that the age of the structure can be enhanced by 10 or 20 years. That is also done. And another thing is efficient resource management, like I said about segregation of waste and utilization of 3D materials for 3D printing. A lot of these things are being utilized by AI, and it is telling about resource management. And of course, we have smart infrastructure. And today, civil engineers are making themselves equipped with the latest technologies and algorithms, which might actually help in better design, better construction, and quality construction. Maybe we will soon reach to from developing to developed countries soon. So this is all small workshops which we do and structural assessment monitoring using AI. And this is all our various participants all over India, and this is our team. So myself, we have Infosys, we have Kyoto University, we have Israel company, Green Vibes, and we have Crystal Profila from Computer Science, PhD students and research students who are all working on this projects. I think I've been little fast in sharing all this, and a special acknowledgement to Dr. Nag Satish Kumar Gar and Anil for giving me this opportunity and share a special on thing on AI and applications of AI in civil engineering and our research work, where we are extensively using AI in automating a lot of work for Indian government. Yeah, now in case any questions, I'll be very happy to take anyone. You can have any questions, I'll be very happy to take. Anyone? Hope you all are able to hear my voice.
Yes, sir.
Yeah, in case anyone, any questions, I'm done with the presentation. In case anyone, I'll be very happy to answer if you have any queries related to the presentation I have did.
Hello, sir. Good evening, sir.
Yes, please. Very good evening, please.
Good evening, sir. This is Sai Teja. Sir,
Yes, sir.
actually, this is not a big question, sir. But
Please.
training the machine is a little bit difficult. Can we train humans also, no, sir? Instead of training machines, we can train humans also, no, sir?
No, I'll tell something here because one of our meetings, India is one of the country where we have a high number of road accidents and as well as deaths as well.
Okay.
So Indian government is working very hard in awareness of road accidents and giving training to a lot of people, giving license. But human behavior will change based on the situations. Suppose you had a morning fight, then the kind of a training would be very different. Suppose you want to go somewhere and you are late, then your driving skill would be very different. So depending on human behavior has becoming very, very challenging, and that is why we are actually going on relying on the machines. This is first.
But sir,
Second thing is, second
one
thing,
thing,
I'll just
sir.
add another thing. Yeah,
Okay, sir.
sorry. Second thing is, right now there are some surveys. Tech Mahindra, I'm part of Tech Mahindra. So we see the call centers where people talk to their customers. Sometimes the customer care and call center, sometimes it becomes very rough conversation. But machines are very kind and they talk to their clients in a very soft way until the problem is solved. They don't keep their phone. So slowly things are trying to, it's not about trying to take over the human beings' jobs, just where some places where human beings are getting tired or where there is a lot of risk, there we are trying to currently fill with the machines.
Okay, sir. But sir,
Yes.
somewhere I have heard or somewhere I have studied, one machine has made a mistake that it is working, the AI robot is working in some database company. It has deleted the whole database of that company.
Right,
I
right. So
that is
debugs are
right.
always there. Debugs are always there. Like recently, also in last 2 to 3 years, people who were following Google Map, one of the car actually has fell into the water.
Yes, yes, sir.
It went onto the bridge and it fell. So still there are some accidents, but when compared to human being accidents, these accidents comparatively seems to be very, very low. But
Yes.
still, But still, government is working very hard, and AI scientists are working very hard to see that all these have actually become zero or null or nil. Yes, but
Yes.
it's a journey. It's a journey.
Yes, sir. Okay, sir. Okay, sir. Fine. Yeah, sir. Thank you.
Yeah, yeah. Thank you so much. Welcome, please.
Sir,
Any other question
good evening,
related
sir.
technical?
Good evening, sir. I am Dr. Ganesh from ADYPU Pune. Sir,
Yes, sir.
I
Please.
thank you very much for your idea on the human intelligence that it is changes according to the situation.
Okay, please.
Because human is working on so many variables and attributes, I think human can never be trained. He has to be developed depending upon the situations. And I think
Right.
machine is right now the perfect intelligence and human is the artificial intelligence. I think, sir.
Okay, in one way it can be said. Yeah, thank you. Thank you for adding that point. Yes, it's becoming very challenged to
Because
train human
it
beings.
is not influenced on any other parameters, sir. It is strictly monitoring the model and it is giving the best results. But human is subjected to lot of influences, sir.
Right, absolutely. I 100% agree to the professor's words in that case. Yes, machines are always given certain, they always have limitation. They'll work only to the certain scenarios, not all the scenarios right now, but they are trying to come up with humanoids. In fact, last week there was Olympics of robots. If somebody has heard about that, China was holding Olympics for the robots. So they're also trying to see, but mostly machines are one-dimensional objective or a multi-point objective, but not as many as human are right now. Things are changing. We have to see what's there in future. But yes, engineering is going to have very good time. Construction is going to change. Designs are going to change. Maintenance are going to change. And it might actually enhance the infrastructure health as well and public's health as well. Yes. Yeah.
Sir,
Any other technical related? Yes, please.
sir, hi, sir. This is Dr. Rajesh.
Please. Chapman.
Sir, I have a doubt regarding like you have modeled 3D things and you can take images and you can develop a 3D model for bridge structures.
Right,
Can
right.
we can
Anything.
we can we do it for a beam or when it is cracked? Can we check
Yes, we are
the
doing that as well.
yes?
See, this is this presentation I have kept as a first lecture, so I have kept in a very common so that everyone can understand.
Okay,
But technically, we are trying to take a thermal image and RGB images of the crack, and we are trying to reconstruct that in 3D, and we are able to see the depth of the crack as well, which in general human being cannot see.
okay, sir. Sir, can I contact you at your leisure time at any part of in ongoing sessions or any other
Yeah,
time?
yeah, sure, sure. This is my email ID. In
Yes.
case anybody is interested, or if anybody is interested to be part of live railway projects, also they can actually contact us. They can be part of that. We'll be very happy because
Sir,
it's not something that I am the only one which who can solve. It's not like that. There are a lot of people, Indian Railways and more required to solve a lot of problems. So somebody is interested, they can always drop a mail and we'll get back to you as well.
definitely, sir. Thank you for the question.
Yeah, yeah. Any other technical? And again,
I
I say,
said,
even though we are working from last 10 years, I only say that our journey has just begun. It's not the end in artificial intelligence. Yeah.
Hi, sir.
Any other question? One? Yes, please.
Hi, sir. This is Chandramouli.
Please.
Sir, just wanted to know these automated damage detections can be done for internal damages also, or this is only on the surface damages that we are getting?
Right. Actually, when I have shown one of the bridge which we were testing,
Yes, sir.
see, drone actually does only the peripheral damages, only visual damages. But
Yes.
there is another study which is called vibration based study where we put sensors on the structure, we get the vibrations, and we are also able to tell about the internal damages as well.
Right, sir. Like echoes and everything, we need to go with IoT or echo-based sensors for detecting the internal damages, right, sir?
So what we have used in our research studies, we have used accelerometer sensors and we have actually measured the vibrations, and then we were calculated the mode shapes, and from mode shapes we were trying to figure out where exactly the damage is and what kind of damage would be. So this is
Okay.
internally. So now the technology is about fusing both vibration and vision based to tell damages which are there outside and as well as inside as well.
Okay, sir.
Yeah, it's a journey of last 10 years. I have compiled in a generic and I have shown some results, but it is almost we are doing from last 10 years on the same thing. But very recently from last 3 years, our results are amazing because we had lot of data, lot of data. That was the advantage.
Okay, sir.
Yeah, and for others
Sir,
also who are interested in getting data, there are a lot of free data repositories like University of California, Irvine, and Norway Technology, NTNU, like National University of Singapore, and USGS. All these websites actually give you free data where you can directly start working on and compile your codes. And as a civil
Okay.
engineering, you don't really need to develop any code. So most of the codes, even though this is a public lecture, I'm telling most of the codes are already there in Google Colab where you can have, and only thing is you have to make a tailor made of that and you can have the online free data and you can train with it. That will give you the first confidence level. After that, you will go on working on, you can actually explore a lot of other things as well, but you can start with it. Google Colab has that, and Kaggle is very good place for public domain of data. Yeah, please.
Okay, sir. Thank you. Thank you, sir.
sir,
Yes.
recently I came across one article which says that on every structure in Japan there are these IoT sensors which with the first tremor, there is a first tremor and second intensity tremor, sir. First tremor which comes 5 minutes earlier, the immediate it sends push notification to the central command, and the central command issues the notification to that particular area that is potential. Is going to happen. Earthquake is going to, an alert is going to be sent. Have you, while you are visiting Japan, did you have an opportunity to look into this aspect, sir?
Yeah, I think one of the first, our first image actually, I think I did not put because we didn't want to bombard. We have worked with Japan, and this system is called Early Earthquake Warning System, EEWS. Early Earthquake Warning System is based on the P wave. The first, there is a P wave, which actually comes P and S surface waves. So when this waves comes, there is a time difference between P wave and S wave. When P wave comes, it will activate the sensors, and all the sensors activate the active dampers. Now, once these are all are activated, they are ready to receive the vibrations. And second thing, these dampers will actually try to protect the bridges from extensive deformations. Yeah, these are there. It is for all the listeners, for all the participants. JICA is JICA is one of the scholarship which are available. You can apply, and for the first time, most of you are completely funded to visit Japan, especially in civil engineers. Please write certain mails to some of the faculties in top 5 or 10 universities of Japan. They'll invite you for the first visit because Japan government is very kind to give lot of funds to Indian, especially faculties, so that they'll learn something in Japan. And all these visits generally will vary from 1 week to 1 month to 6 months. You can plan that. You can go with JICA projects and just see JICA scholarships, and you might get and go. Yes, we have gone through that. We're very fortunate to visit those places as well. Most of the structures are installed with sensors, seismic sensors and accelerometer sensors and strain gauges. Yes, they are there.
Hello, sir.
Yeah, any other thing? Yes, please.
Good evening, sir. I'm Dr. Rahul Kumar. Sir,
Very good
where
evening,
we
Mr.
can
P.
get the data set of for a study purpose? Can you
So
give some idea?
yeah, I told already there are repositories online. Kaggle is one of the free Kaggle, Kaggle, Kaggle.
Yes, sir. That I know, but there is genuine data is
I'll
not
tell.
there. So,
There is another data set. University of California, Irvine has got a free data set, and you also have Google data sets and ML repository. And now, right now, interestingly, American Society of Civil Engineers, ASCE, has also started to reposit certain kinds of data, which are like, there are authors like me. When we publish a paper, we'll also send some data to ASCE. So all this data is currently kept under ASCE as well. So you can
Yes.
actually go. And if you want government data set, you have data.gov. Data.gov are the government data set, and data.gov is US, data.gov.uk is UK, and data.gov.in is India. So these are all some sites where you get all this data. Apart from that, if you want more data, I suggest that you just drop a mail to some of the researchers who are publishing papers through ResearchGate,
Yes, sir.
and this data is available. Yeah, somebody is
Sir,
interested in working on bridges, then please visit NTNU. They got a lot of data, vibration data, video data, a lot of data is there on NTNU website, please. Yes, please.
if I send to you, sir, can you provide some data set for bridges?
Yeah, there are some data sets which we have kept already online. If somebody is interested, you can drop a mail and then we will share those links.
Okay, thank you, sir. I will
Thank
mail
you.
you,
Thank you.
sir.
Sure. Thank you.
Sir,
Yeah,
hi sir.
yes,
Yeah, hi
please.
sir. This is Chaitanya from RVR, sir. Sir,
Please.
there are 1032 data set is there. Can we use it and we can work on it? It is okay, sir.
Absolutely fine. See, when you are working on data for the first time, it is only for your experience. You might not get the accurate results, or your accuracy may not be more than 75% or 80%, but you will try to understand what is the variety of data and what kind of data you need to fine tune your results. That will help you. But for the first, how to use the code, how to give input data, how to get the training of the data, how do you validate data, how do you do the testing of data, and what percentages and all. This is what first we need experience, because most of them don't do this. We feel ML is challenging. The most easiest thing is ML, because we are not training ourselves, but we are training machines, and we are not trying to develop any codes. Codes are already available, but data is
Yeah.
most important.
Yes, sir. Data is the most important, sir.
Whether it is reliable to use the data which is available.
You will know that, because based on the accuracy, based on the variation of the data, you can try that. Like
But
we
finally it
use
will
when
give
we
the R square value, na? Then whether to do based on the data, whether it is reliable and do on any ANN model or like that or K like that, and we can work on it and publish on it. It is okay.
Yeah, it is absolutely fine. Especially when you are publishing, you will give the acknowledgement to the data set where you have downloaded. Yeah, but
Yeah.
as you said, not all data will give you complete picture, which might be used for publication, because most of these data are already used. All you have to do is maybe you need to add another 10% of the data, which is trying to fine tune all your results, or accuracy is increasing, or maybe you are trying to combine some 2 or 3 algorithms. Like, even though we are
Yeah.
using deep learning, for classification, again, we will use simple classification, supervised learning only, because it has to tell it is a crack. It
Then
has
we
to tell
can
it is a
do
spelling.
clustering is possible in that.
Yeah, it is possible.
Okay.
See, after our computer classifies all kinds of damage, we give the names based on, again, supervised learning only. So we are trying to utilize 2 or 3 algorithms at the same point of time.
Yeah.
Yeah, so that is what is your innovation. So to tell something, quantify something, you are trying to use 2 or 3 algorithms and giving result. Yes, all those results will be utilized for your publications.
Okay. Okay.
In case if you are interested in publication. Else, to solve problem, yes, you can.
Yeah. Yeah. Thank you.
Yeah, thank you.
Okay, sir. Thank you. Thank you very much.
Okay. First, lastly, thank you so much, all the listeners at this point of time attending this lecture. Special thanks from my side, and special thanks to organizing committee again for inviting me to deliver lecture on applications of AI in civil engineering. Thank you so much. One small quote, and I'll end here. For all the participants, if you want something you never had, then do something you never did. If you want something you never had, then do something you never did. With this, I wish you all the best. Thank you so much once again. Have a good time. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
So the second resource person is also ready, sir. So, so the session starts in another 2 minutes. I'll just give a brief description about the second resource person, sir. His name is Dr. P. Sridhar. So he is an expert in geoinformatics. So he is so he so he's presently working as an senior faculty engineering staff college of India, Hyderabad, and he has presently has an extensive experience in spatial data analysis and geodatabase design. So he has led projects in modeling and also land use, land cover changes, mapping urban growth patterns, and assessing environmental impacts. So he has mainly worked under SWAT analysis, soil and water assessment tools. So he has hands-on experience on GPS and GNS surveys, and he has recently published a book on GIS-based experiments recently in January 2025. So I now hand over the session to Dr. P. Sridhar, resource person 2 for this session. Dr. P. Sridhar, sir.
Yes, sir. Am I audible to you, sir?
Yes, sir. You are audible, sir.
Thank you. Thank you very much for your brief introduction about me. Just I would like to share my PPT. Yeah. Is it
Yes,
visible
sir.
to you, sir? This one?
Yes, sir.
My
Yes, sir.
PPT.